everybody. Today we're doing lesson 7, which is solving linear quadratic systems. So we're kind of returning back to systems of equations for a second with this lesson because we can have a system of equations that is composed of a quadratic and a linear function. And we can find those solutions now that we're dealing with quadratics. So a system of equations involving both a linear function and a quadratic function is known as a linear quadratic system of equations, which is kind of makes sense. The solution to these systems can be found graphically, or now we can do it algebraically. So if we consider the system of equations below, we've got the first one, y equals x squared minus 8x plus 15, and then we have y equals x plus 1. If we solve this graphically on the grid and label our equations, what we're going to get is something that looks like our parabola with a line crossing right through it. Now, we were really supposed to be doing this by hand, which I know is not everybody's favorite, but what we can do is put it in the table and get our points from there because we have to do this graph by hand. Oops. Okay, so x squared minus 8x plus 15. I'm going to put this in so I can look at the table. Second table, okay? And I'm going to start off with 0 here. I'm just going to write the table in so I can plot some points. 0, 15. I'm going to start here because I don't have negatives. 0, 15. 1, 8. 2 and 3, 3 and 0, 4 and negative 1, 5 if I go down, 5 and 0, so you can see where your turning point was. It's starting to repeat. 6 and 3, and 7 and 8. And I'll just go to 8 so that we can have the full repeat of numbers there, okay? So I got that from here, right? If I take a look at the graph, I'll be able to see where the zeros are. Let me just zoom standard, which is 6. And I'll be able to see where my graph looks like it's going to be, and that's why there were no negatives included on this graph, right? It's just all positives here, okay? So I know where my turning point is just from looking at this, right? It's the 4, negative 1, because that's the point where all the numbers start to repeat. So I'm going to start off by plotting that point. So 1, 2, 3, 4, 5, 6. So you guys go ahead and label. We have to go all the way up to 15. Okay, so 4 and negative 1 is here. That's my turning point, right? And now I can start plotting the rest of the points. I have 0, 15, 1 and 8, 2 and 3, 3 and 0. And there's my turning point, 4, negative 1, 5 and 0. Now they start to mirror. 6 and 3, 7 and 8, and finally 8 and 15. Okay, so connecting those points, we have our lovely little parabola, just like the one we saw on the graph. Okay, and now for the second, we have x plus 1, so you can just, again, you can plug it in here. And let's make our lives a little bit easier. All right, we know that our y-intercept is at 1 because it's right there. Okay, and this is a slope of 1. So it's up 1 over 1. So up 1 over 1, up 1 over 1. Okay, and that's pretty much enough. I can draw a line through here. Okay, and the final step is to label these two equations. So the first one, the parabola, is my y equals x squared minus 8x plus 15, and the line is my y equals, x plus 1. So now, what are the solutions to the system of equations? There are two here, right? So I have one here where they cross and one here where they cross. So those 2 points are 2, 3, and we have another at 7, 8. Okay? So how is this different than the ones that we did in the first unit talking about systems of equations? Well, we were just dealing with linear equations, and so we had only one solution. Because a parabola loops, when you have a linear crossing over it, you're going to have 2 spots where they cross, usually, okay? Now, let's get into the fun stuff. We're going to solve the system algebraically in part B using substitution. Okay, so we're going to show all the work. So this one is kind of nice because we have that y is equal to x plus 1. So what I'm going to do is everywhere I see a y in the first equation, I'm going to replace it with x plus 1. So where is the y? It's here. So in here is going to go the x plus 1. Okay, so I'm going to write x plus 1 is equal to x squared minus 8x plus 15. So maybe you're having a little premonition here about thinking about what's going to end up happening. We're going to end up having this set equal to 0, and then we're going to be able to factor and find our answers. Okay, so let's see what happens. All right, first I'm going to subtract the x from both sides over here, and I'm left with 1 equals x squared, and then negative 8 minus x will give me negative 9x plus 15, and now I'm going to subtract 1 from both sides. This gives me 0 equals x squared minus 9x plus 14. So now I'm going to be able to use this to solve. So I'm going to rewrite this with the 0 on the right. So x squared minus 9x plus 14 equals 0. So I'm going to factor, and then I'm going to solve. So leading coefficient is 1. I'm going to double bubble. This is an x and an x. Last term's positive, so they're the same signs. Middle term's negative, so they're both negative. What two numbers will multiply together to give me 14 and add up to negative 9? That'll be negative 7 and negative 2. So here we go. Find your two zeros. X minus 7 equals 0. Add 7 to both sides. My first 0 is x equals 7. And my second 0, x minus 2 equals 0. Add 2 to both sides. My second 0 is x equals 2. Now, I was supposed to be doing this to solve the system, but what I found were two zeros. So how does that help me? What can I do here? I can take these two x's and I can plug them into the equation, the original equation, y equals x plus 1, and it'll give me the corresponding y value. Okay, so let's take a peek. Let's start with the x minus 7. Okay, I'm going to go into y equals x plus 1, which is much easier than the other one. So y equals 7 plus 1, y is equal to 8. So when x is 7, y is 8. So that gives me the first solution, 7, 8. And then I'm going to, because I have two solutions, I'm also going to plug in the 2. So y equals 2 plus 1, or y equals 3. So when x is 2, y is 3. So my second solution is 2, 3. And that's how we would get the same exact thing algebraically. Ta-da! Okay. So finding the intersection points of lines and parabolas can be challenging graphically, but sometimes it's more easy to do it algebraically. Okay. In this case, it was pretty simple, but a lot of the times we'll see what happens where we can't get the exact value because it's not an integer, like in our previous lesson. So let's take a look at exercise number 2. We're going to find the 2 points of intersection of this quadratic and linear function shown below, but we're going to do it algebraically. Okay, so remember, even though this says f of x and g of x, these are really both y. So basically what you're going to do each time is you're going to set them equal to each other, which is the same as substitution. So I'm going to have here x squared minus 3x minus 17 is equal to 5x plus 3. And basically what I'm going to do is I'm going to get it equal to 0 on the right, and then I'm going to factor so that I can find the zeros. Once I find those zeros, those are the solutions in the x coordinate, and then I'm going to plug the x coordinate back in to find y, just like I did here. So let's do this. First I'm going to subtract 5x from both sides, and I'm left with x squared minus 8x minus 17 equals 3. And I'm just going to subtract my 3 from both sides, and I have x squared minus 8x minus 20 equals 0. Now it's time to double bubble. Okay, so we have a leading coefficient of 1, so it's x and x. X and x. My last term is negative, so I'm going to have a plus and a minus. And the middle term tells me which one is larger, so my larger number is negative. So what two numbers will multiply together to give me 20 and add negative 20 and add up to negative 8? So we're thinking of the factors of 20, so 10 and 2 are going to work. 10 and 2, the bigger one is 10, so that's the negative. So this is x minus 10 and x plus 2. Just to make sure, you can always double check. 2 times negative 10 gives you negative 20, and negative 10 plus 2 gives me negative 8. All right, we're halfway there. More than halfway there. Now we set each piece equal to 0, and we'll solve and find our two x values. One sec there, Drew. Subtract 2 from both sides. X is negative 2. And over here, add 10 to both sides, and x is 10. So these are my x coordinates. All I have to now do is go back into the easier equation, plug it in to find the corresponding y coordinates. So I'm going to just box these so that I don't forget where they are real quick. So let's go back to the first one, which was easier, 5x plus 3. And I'm going to plug in x equals negative 2 first. So y equals 5 times negative 2 plus 3. That's negative 10 plus 3, which is negative 7. So my first solution point is negative 2 comma negative 7. Okay, and then the second one is going to be, we're going to plug in 10. So 5 times 10 plus 3, that's going to give me 53. That's my second y coordinate, goes with 10. So it's 10 comma 53. So to just write them together, negative 2, negative 7, and 10, 53 are my final solution points. Okay? Okay, so for the next page, when we're solving these types of systems, we have to be prepared to use the zero product law and factoring in all of its various forms. So exercise 3 is going to give us a look at a different type of factoring instead of it just being very straightforward like the previous two ones we just did. So, first things first. We're finding the x coordinates only here, so we don't have to go back and get the y's this time. Only the x coordinates, which means we just have to find the zeros. Oh, sorry. So I'm going to set these equal to each other. Basically, all I'm doing is I'm taking what y is equal to and replacing it here. Okay? So this is going to be x squared minus 12x plus 7 is equal to negative 8x plus 7. Okay, and I'm going to solve so that it's equal to 0. So let me add my 8x to both sides. That gives me x squared minus 4x plus 7 equals 7. Now I'm going to subtract 7 from both sides, and what am I left with? I get x squared minus 4x equals 0. So this looks slightly different than what we were dealing with before. It's not going to be a double bubble, right? We just have to think, how can I factor this? Because you are able to factor it. So we always want to be thinking of GCF. Always, always, always try to factor GCF first. So x squared and 4x, they both have a common factor of x. So I'm going to factor out the x, and then I'm left with x minus 4 equals 0. And now this is it. It's nice and simple. Split it up. X is equal to 0. That's your first 0. And then x minus 4 is equal to 0. Add 4 on both sides. X is equal to 4. These are my two zeros. Okay, so as a solution, set that'll be 0, 4. So let's look and see what option that is. Choice 3. Okay. So final look at a linear quadratic system. This is a special case, okay? So we're going to take a look at y equals 2x minus 4 and y equals x squared minus 4x plus 5. First, we're going to solve it algebraically. So why don't you guys try that and then unpause. Okay guys, so if you solve this algebraically, what you find at the end is that when you factor it out, you're getting, this is a perfect square trinomial, so it's x minus 3 times x minus 3. So as I showed you in a previous example the other day, if they're the same, you only have to write one solution. You can't have two zeros at the same point being separate. That just means it's the same 0. So x is equal to 3 is the one and only 0 here. So when you plug it back in for the easier equation, you'll get that the y is 2, so your point is 3, 2. So now let's take a further look. We're going to look at it graphically by graphing both equations on the grid provided. Okay? When you have a line that only touches something once, only one point, and it doesn't cross it, it's called tangent. And you're going to be using that word a lot in high school. In geometry, it's going to be a huge, important concept. So this is your first real exposure to the tangent. They don't intersect, they touch once, and that's it. Okay? So imagine, here's my calculator, and my pen is touching the very edge of my calculator only once, and then they'll never intersect again. That's basically what it means to be tangent. So when we look at these equations, we're going to see that. So I'm going to do this in the calculator to show you. Oops, it's not on. That would be good if it was on, right? So let's clear this. We have 2x minus 4, and then we have x squared. X squared. I'm not looking while I do this. Minus 4x plus 5. Okay, so let's take a peek at the graph. Okay, here comes our parabola. If I zoom in on that, what you're going to see is that it's only crossing one time. Only once. Okay, let's see, it's going to be right about here. Boop, oh, I can't see it. All right, hold on. I'm going to zoom out, and then it's going to go back. I think I just didn't center it right. Let's try that again. See, this is good for you guys to see. Zoom in, but you have to move your cursor. See, it was over here. I thought it was over here. So if I move my cursor closer to where I want to see, and then I push enter, now it'll zoom in on the spot I want to look at. Okay, so, aha, see, there's one point here where they're intersecting, and that's not even intersecting, they're touching at that one point, okay? Now, if I do a trace here, it's thinking the intersection point is 2.99994, 1.999. Look at how close that is to what we have here. 3 and 2. When you do it in your calculator, it doesn't always give you the exact answer, and that's why we want to look at the algebraic ways. Okay? So, anyway, if we graph this, 2x minus 4, that means my y-intercept is negative 4. Here's my negative 4. And my slope is up 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and so on. Okay. Just get your little line through there. Okay, and I will do the table for this equation. I'm just going to look at it so that we don't get confused. 2 and 1. Let's see if we can find our turning point. turning point is 2, 1. Okay, so that's 2 and 1. And then we have 3 and 2 here. As you can see, that's supposed to be right where our turning point is. I mean, our intersection is. 4 and 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, and in the opposite direction, we have 1 and 2. Then we have 0, 5. 1, 2, 3, 4, 5. 1 and 2. Okay, so you can see it's starting to show here. You can keep going if you want. 5 and 10. And then I'll do one in the opposite direction, -1 and 10. Okay, and then we'll connect here. Whee! And you can see how it only is intersecting that one little spot there. Okay? So how many different possibilities are there for the number of solutions to a linear quadratic? So what does this mean? We can either have no solution, right? Think about it. If these aren't touching at all, there will be no solution at all. We could have one solution, like this one, or we could have two solutions, as is typical. So there are three possibilities. Oh boy. Don't tell me spell so early. Oh my gosh, I can't spell right now. Possibilities. Okay, was I right the first time? Oh, okay. All right, so that's it, guys. So you can always take a look at these in your calculator, but if you want to get an exact answer, you're going to want to do it algebraically. Okay, have fun with this.